In the previous video, we were discussing about different robot configurations. So in that, we understood uh, two configurations of the robot, that is Cartesian configuration of the robot and cylindrical configuration of the robot. So another two configurations of the robot, that is polar configuration and jointed arm configuration of the robot, are left. So in this video, we'll understand what is polar configuration of the robot and what is jointed arm configuration of the robot. So we discussed about this Cartesian or rectangular gantry type of robot. We understood how this robot works, and we understood cylindrical configuration of the robot also. So next we have polar or spherical configuration of the robot. So in this robot we can observe this robot configuration and this robot configuration almost same. Cylindrical configuration of the robot. Okay, you can observe the diagram. So this is and uh, another configuration, that is okay, cylindrical configuration and polar configuration. Okay, looks almost same. Okay, so this is also having a base and one solid cylinder, and outside, okay, another, the solid cylinder is inside the another small, okay, we can see the hollow cylinder, and the same, but the motions, okay, are the movement of the joints in the robot having, okay, different type of movement. You can see this can rotates on its own axis. Okay, it was observed in this also. We can have rotary motion in this also, and in this also we can have a rotary motion, polar cylindrical configuration. And in this one, okay, we can observe here it can have only linear motion up and down, but here it is different, that is it can have a rotary motion here also, and it is same. So here in polar or spherical configuration we have two rotary motions in the robot configuration and one linear motion, but previously in the cylindrical configuration only one rotational motion of the robot and two linear motions of the robot. That is the main difference. This is called the polar or spherical configuration of the robot. The last one, that is called jointed arm configuration of the robot. We can see in this robot, okay, we have joints. This is the one joint and this is the another joint, and if we have another joint here, okay, another joint here, all these joints, okay, can have only rotary motions in the joints. So this is called jointed arm configuration of the robot. We can observe the arrow marks. It can rotate on its own axis 360-degree. That is the one, okay, rotational motion of the robot joint. And here it can rotate, and here also it can rotate, and here also it can rotate. So like this, only rotational motions in the joints of the robot, that is called jointed arm configuration of the robot. So we can observe in this diagram how the industrial robot looks. What are all the different parts of the industrial robot? We can see in this diagram, this is the base of the robot, and this part is called as arm and body assembly of the robot, and it can have rotational motion. This whole assembly can rotate on its own axis 360-degree. So that is rotational or transverse motion of the robot. And radial transverse, it can move like this also, in and out, and it can rotate. Here this part can rotate, okay, wrist bend and wrist assembly, we call this as a wrist assembly of the robot. And this is the gripper, this part is called as the gripper. It can grip some object by using this gripper. We can design the gripper in different ways based on the type of object and shape of the object it is going to grip. And this is called the wrist swivel, and we can see wrist on. So like this, the robot can have different type of motions by using different types of joints and links. So what are the different types of robot motion system? How the robot can have different, okay, motion systems? One is called point to point, or it's also shortly called as PTP control robot. And second one is called continuous path, CP control robot, and controlled path robot. Okay, so these are all the three different types of robot motion system. So here the robot will move from one point, okay, it will move to this point, again it will move to the next point. So like this, okay, point to point control, from one point to another point it can move. And some other robot can have the motion continuously, it will be moving. So that is the called continuous path control robot. Another one is called controlled path robot. So like this, we have three different robot motion systems in the robots. So next one, we'll understand about technical features of an industrial robot. What are the different technical features? Okay, if you wanted to buy a robot or if you wanted to use a robot for a particular application, so what are the technical features we have to look into, we have to consider to do that particular task? One is the degrees of freedom. Degrees of freedom, shortly we call this as a DOF, degrees of freedom, work volume or workspace, and precision movement of the robot, control resolution, okay, and accuracy, repeatability, speed, weight carry capacity. Okay, so these are all the main technical features of any industrial robot we have to consider before designing the robot or before using the robot for a particular application. So you'll understand one by one what are all these technical features of an industrial robot. First technical feature of a robot, that is called degrees of freedom, DOF. I think you know already what is degrees of freedom. That is, okay, so how many types of motion a robot can have. Okay, linear motion and rotational motions in the robot. Okay, in the space, if you take any object, that object can have 6 degrees of freedom. Okay, so there are three axes, x, y, and z. We can have three linear motions and three rotational motions in the space. So like this, okay, so we have to see how many degrees of freedom a robot is having. That is the one main important technical feature of the robot. Each degree of freedom can be rotary or slider or linear motion or other type of actuator also we can have in the robot. Robots typically have 5 or 6 degrees of freedom. Okay, maximum 6 degrees of freedom any object can have in the space. Like this, robot can have maximum or typically have 5 or 6 degrees of freedom. So next one, workspace or work volume. This is also another important technical feature of the robot. We can observe there are four different configurations of the robot. This is the one type of robot, and this is another type of robot, and this is another type of robot, and this is another type of robot. Like this, four different types of robots we have. And in this, what is work volume or workspace? For example, you have a robot and you will keep the robot in a particular place up to what maximum length the robot can reach. Okay, we can see this can move up to this point maximum. Okay, whatever the dotted lines in this, we can see the box. This is the maximum volume or workspace the robot can cover in a particular place. That is called the work volume or work space. And if you see this robot, okay, so this robot can reach or it can cover this volume. Okay, so it can cover whatever the dotted lines you are seeing here. So this is what the space or the volume the robot can cover. And this robot also we can observe how much volume or the space it can cover. And this robot also we can observe. This is called the work volume or the workspace. This is also very important technical feature used in the industrial robots. So next, that is precision movement. Okay, there should be always precision in movement of the robot. So that is control resolution, smallest change that can be measured by sensor. We are going to use sensors in the robots to sense different things. Okay, so that a sensor, okay, should measure a smallest change in the robot motion. And accuracy, okay, robot should be accurate in, okay, doing the work. Okay, and repeatability means if you do any work repeatedly, there should not be more errors. Okay, error should be minimum. If you do one task repeatedly, there should not be error. Okay, it has to do the work perfectly without any error. That is called the repeatability of the robot. Next one is the weight carrying capacity. So how much weight the robot can carry. So that is also another important technical feature. So here we have to consider this also one of the important technical feature, because based on your application, we have to choose the robot. Okay, how much weight the robot can lift and it can do the task. Okay, so that's why the weight carrying capacity is also one of the important technical feature of the industrial robot. So speed, okay, so if you give some instructions to the robot, at what speed it is going to respond. Okay, so response time should be minimum. It has to respond to your instruction very okay, fastly, and then you can it can do the task very fastly. So that's why speed is also one of the important technical feature. So next, what are the different types of drive systems used in the industrial robot? We need some drive system to drive the industrial robot. So that is, we can use hydraulic system. We can use the hydraulic system, and we can give different motions to the robotic joint. How we are going to give the different motions to the robot? One thing we can do is we can use electrical motors. We can give rotary motions, or we can convert the rotary motions into a linear motion by using some mechanism. For that also we require some electrical drives, or we can use hydraulic drive, we can use electrical drive also, and we can use pneumatic drive also. Wherever you don't want more capacity or more, if you are doing very heavy works, then we can go for hydraulics, and if you are doing very light work, we can go for pneumatic drive in case of robots. And we can use electrical drive also, where we have some medium, okay, work you are doing by using a robot. Okay, so like this we can use three different types of drives in the robot. First one is the hydraulic drive. Okay, we have to give some motions to the robotic joints to do the work. So that is done by using hydraulic drives. We can use hydraulic motors, we can use hydraulic cylinders, and we can give the different motions. So like this we can use electric motors also, and we can use some other electrical devices to give different motions to the joints of the robot and links to the robots. And pneumatic drive also we can use. So like this, these are all the main, okay, drive systems used in the robots. So next one, programming the robot. Okay, how to do the programming of robot? Okay, so what are the different methods of programming? The first method is called manual method of programming. Manual method of programming. Second one is called walkthrough method of programming, and lead through method of programming, and last one is called offline method of programming. So like this, there are four different methods used to do the programming to the robot to do a particular task. So we'll understand one by one what is manual method of programming. It is the procedure used for simpler robots and involves setting mechanical stops switches in the robot control unit used for pick and place robot. Okay, so what is manual method of programming? How do you do the manual method of programming? Is it entering data manually into the in the computer to feed into the robot the programming? No, it is not like that. It is the procedure used for simpler robots and involves, we can observe, setting mechanical stops switches in the robot control unit. Okay, robot will be having a control unit. In that control unit, we are going to set some mechanical stops. Okay, some mechanical elements there in the control unit. In that control unit we are going to set them properly. So, and again some switches we are going to set it properly in the robot control unit. That is called manual method of programming the robot. So generally this is done for pick and place robot. Here the pick and place robot means the robot is going to pick something from one place and placing it to the another place. Okay, place it to the other place. So that is called pick and place robot. It will pick the object from one place and place it to the another place. That is called pick and place robot. Generally this manual method of programming is used for simpler and pick and place type of robots. Next we have walkthrough method of programming the robot. What is this walkthrough method of programming the robot? In this method, the programmer manually moves robot's arm and hand through the motion sequence of work cycle. This is used for spray painting and arc welding applications. So here, generally the programmer, what he will do is he is going to move the robot after constructing the robot or manufacturing the robot. He is going to check whether the robotic arm is moving properly according to the sequence, work cycle sequence. Okay, so in this fashion only the robotic arm has to move. So whether it is moving properly or not, he is going to check it. So that is called walkthrough method of programming. He will check properly, and he will give some training to the robot by moving the robotic arm in different ways, in different motions according to the sequence of work cycle. That is called the walkthrough method of programming. So in the next video, we'll discuss more about the other programming methods. We'll learn what is the other programming methods of robot. Thank you.